Take a moment and run your tongue along the back of your molars. You might feel a tiny, jagged ridge, or perhaps a microscopic bit of grit from your lunch, a sesame seed, maybe, or a fragment of a grain. It's a small, annoying sensation, something you'd usually ignore or try to brush away without a second thought. But that tiny point of contact between your tooth and a hard object is actually the single most important interaction in the history of your species. For millions of years, that sensation of grinding, cracking, and tearing was the only thing that stood between your ancestors and the cold silence of extinction. We like to think of our history as a series of grand ideas or great battles. But in reality, the story of humanity is written in the wear patterns of our teeth and the chemical signatures left behind by what we swallowed. Everything you are, your brain, your culture, your very ability to sit here and wonder about the past, is a byproduct of a 3-million-year-old search for a better lunch. To understand what we really are, we have to look past the myths of the paleo diet and follow the deep time journey of the human gut, starting with a version of ourselves that didn't even know how to hunt. If we go back roughly 3.5 million years to the era of Australopithecus afarensis, the species made famous by the Lucy fossil, the menu was a lot more colorful than you'd expect, though much harder on the jaw. These early relatives of ours lived in a world that was slowly drying out, a shifting mosaic of forests and expanding grasslands. For a long time, the prevailing theory was that they were strictly vegetarians, munching on soft fruits and leaves like modern chimpanzees. However, when researchers like Dr. Matt Sponheimer at the University of Colorado began looking at the stable isotopes of carbon in their tooth enamel, they found something surprising. These ancestors weren't just eating forest fruit, they were consuming C4 plants, which include grasses and sedges. Now, humans can't actually digest grass, unless you want a very painful stomach ache, but we can eat the succulent underground storage organs of those plants, the tubers, rhizomes, and bulbs. This suggests that the mundane part of the human diet, the humble root vegetable, has been a staple for millions of years. But there was a catch. Eating raw, fibrous tubers requires massive chewing power, which is why your ancestors from this era had massive, flat molars and thick jawbones. They spent hours every single day just grinding away, which, as anyone who has tried to eat a raw sweet potato can tell you, is a full-time job. But as the landscape of East Africa continued to change, a new opportunity arrived, one that was slippery, gray, and hidden deep inside the bones of dead animals. Around 2.6 million years ago, a new kind of tool started appearing in the fossil record, the Oldowan stone flake. These weren't weapons for hunting, they were essentially the first kitchen knives. Our ancestors, likely Homo habilis at this point, were starting to scavenge. When a saber-toothed cat or a giant hyena finished its meal, it would leave behind the thickest bones of the carcass, the femurs and humeri, which were too tough for even the most powerful jaws to crack. Our ancestors realized that while they didn't have the teeth of a predator, they had the hands to use a rock. By smashing these bones open, they accessed the bone marrow, a substance that is nearly 90% fat. This was a nutritional nuclear bomb in a world of lean, fibrous plants. Marrow provided the dense calories needed to fuel a growing brain, but it also changed the way we interacted with the world. We weren't the kings of the savannah yet, we were the clever opportunists, the ones who waited for the scary things to leave so we could pick the trash. This scavenging phase was so successful that it likely triggered the expensive tissue hypothesis, a theory proposed by Leslie Aiello and Peter Wheeler. It suggests that as we started eating more energy-dense food like marrow and scraps of meat, our energy-hungry digestive tracts could afford to shrink, allowing that extra energy to be diverted to a much more demanding organ, the brain. As the millennia rolled on, our ancestors stopped just waiting for leftovers and started taking control of the menu. By about 1.8 million years ago, Homo erectus had emerged, and with them came a change so profound it altered our physical anatomy forever. They were the first to truly master the art of the long-distance chase, but their most important discovery wasn't a better spear. It was the control of fire. The evidence for the earliest human-controlled fire is a subject of intense debate among archaeologists, but some of the most compelling clues come from Wonderwork Cave in South Africa. Deep inside the cave, researchers found microscopic traces of wood ash and burned bone fragments dating back a million years. This wasn't a wildfire, it was a hearth. Fire changed everything because cooking is, in essence, external digestion. By heating meat and tubers, we break down the complex proteins and starches before they even hit our mouths. This meant we could extract significantly more calories from the same amount of food with much less effort. It's the reason your jaw is so much smaller and weaker than a gorilla's. We outsourced the work of eating to the flames. Interestingly, and this is a detail that would make most modern chefs cringe, this early cooking wasn't about flavor. It was about survival. A piece of roasted meat doesn't just provide more energy, it also kills the parasites and bacteria that would have otherwise made scavenging a deadly gamble. By the time we reached the era of the Neanderthals and early Homo sapiens, roughly 300,000 to 40,000 years ago, the human diet had become an incredible exercise in regional adaptation. For a long time, we pictured Neanderthals as hypercarnivores, the ultimate hunters who lived almost exclusively on woolly mammoth and reindeer steak. And while they certainly were elite hunters, the isotope levels in their bones often matched those of apex predators like wolves or lions. New research is painting a much more complex picture. A fascinating study led by Dr. Amanda Henry examined the dental calculus, basically fossilized plaque, of Neanderthals from Shanidar Cave in Iraq and Spy Cave in Belgium. What she found was a revelation. Trapped in their teeth were starch grains from wild barley, legumes, and even water lilies. Some of these grains showed signs of being cooked or toasted. In Iraq, they were even eating cooked tubers. It turns out that even in the harsh environments of the Pleistocene, humans were incredibly resourceful at finding carbohydrates. This was a necessity, not a choice. A human body can only get about 35% of its calories from protein before it hits a wall called rabbit starvation, where the liver can't process the nitrogen fast enough. To stay alive, our ancestors had to find fat and carbs, even if it meant digging through frozen dirt for a single root, a task that is as backbreaking as it sounds. But of all the things our ancestors ate, perhaps the strangest was their emergency storage system. In Kizum Cave, located near modern-day Tel Aviv, researchers discovered something that fundamentally changes how we think about ancient food security. They found a collection of fallow deer metapodials, the lower leg bones, that showed very specific, unique cut marks. These bones weren't cracked open immediately after a kill. Instead, the marks showed that the skin had been left on the bones for up to 9 weeks, acting as a natural ken to keep the marrow inside fresh. This was a 400,000-year-old version of a pantry. Our ancestors weren't just eating what they found, they were planning, storing, and preserving. They understood that the marrow inside a bone would stay nutritious long after the meat on the outside had rotted away. This ability to delay gratification and save food for a rainy day, or a snowy month, was a massive cognitive leap. It showed that we were no longer just living meal to meal like other animals, we were starting to manage our environment. This was the same era where we see the first evidence of humans eating seafood. At Pinnacle Point in South Africa, there's evidence that early modern humans were tracking the phases of the moon to know when the tides would be low enough to harvest shellfish. Mussels and limpets provided a steady, reliable source of protein and omega-3 fatty acids, which many scientists believe acted like rocket fuel for the evolution of the modern, complex human brain. As we move toward the end of the last ice age, around 15,000 to 20,000 years ago, the grand buffet of the human diet reached its peak. This was the era of the broad-spectrum revolution. Humans were eating everything: birds, small mammals, fish, hundreds of species of plants, and, surprisingly, the first versions of bread. For decades, we believed that bread was an invention of the agricultural revolution, something that only happened after we settled down to farm wheat 10,000 years ago. But in 2018, a team of researchers at a site called Shabaka 1 in Jordan found the charred remains of a flatbread that was 14,400 years old. This was 4,000 years before the first farm existed. These people were gathering wild cereals, grinding them into flour, and baking them on hot stones. It was a labor-intensive process that produced a high-energy, portable food. But here's the irony. This advance in our diet was actually a double-edged sword. As we started to rely more on these calorie-dense grains, our dietary diversity began to shrink. We were trading a wide variety of wild foods for the sheer volume of a few specific ones. We were becoming experts in a very narrow field, and our bodies were beginning to pay the price. Then, about 10,000 years ago, the great bottleneck happened: the agricultural revolution. It's often taught as a triumph of human ingenuity, but from a biological perspective, it was a disaster for the individual human. When we transitioned from hunter-gatherers to farmers, our diet shifted from hundreds of wild species to just a handful of domesticated crops, mostly wheat, rice, or corn. This created a massive nutritional monoculture. If you look at the skeletons of the first farmers compared to the hunter-gatherers who lived just a few centuries before them, the difference is shocking. The farmers were shorter, their bones were thinner, and for the first time in human history, their teeth were riddled with cavities. The constant intake of carbohydrates from grains fueled the growth of Streptococcus mutans, the bacteria that cause tooth decay. This was essentially the birth of the dental industry, though it would take a few thousand years for the toothbrushes to arrive. We had more food than ever before, which allowed the population to explode, but the quality of that food had plummeted. We had traded the diverse, nutrient-rich paleo menu for a life of monotonous porridge. This transition is why many of our modern health problems exist. Our bodies are still biologically tuned to the varied, high-fat, high-fiber diet of the savanna, but our environment is now a literal field of sugar and starch. If you look at the Hadza people of Tanzania today, one of the last groups on Earth who still live as hunter-gatherers, you get a glimpse of what our ancestors' relationship with food really looked like. They don't have meal times. They eat as they go, opportunistic and constantly scanning. Their favorite food is wild honey, which they will risk their lives to get from high trees, enduring hundreds of bee stings for a single honeycomb. To them, the richness of a food is its only metric. They don't worry about cholesterol or balanced diets because their environment provides the balance for them. They eat fiber-rich tubers, lean wild game, and massive amounts of berries and honey when available. Interestingly, their gut microbiomes are among the most diverse ever recorded. They carry bacteria that help them break down tough plant fibers that a modern Western gut can't even touch. When we look at the Hadza, we see that the human diet wasn't a set list of ingredients. It was a strategy. It was a relentless, creative, and sometimes gruesome quest to squeeze every possible calorie out of a landscape that was often trying to kill us. We are the descendants of the people who were willing to eat the things no one else would: the marrow, the brains, the rotted meat, the bitter roots, and the stinging honey. But there is one more part of the human diet that we often try to ignore, the part that shows up in places like Gough's Cave in England. Around 14,700 years ago, a group of humans lived in this cave, and the archaeological record they left behind is chilling. Among the remains of horses and red deer, researchers found the bones of at least 6 humans. These weren't victims of a simple murder. Their bones were processed with the same meticulous care as the animal bones. They were defleshed using stone tools, and the long bones were cracked open to get to the marrow. The skulls were even shaped into drinking cups. For a long time, we wanted to believe this was a sign of desperate starvation, but the evidence says otherwise. There was plenty of animal game in the area. This was a choice. Whether it was ritualistic or a way to honor the dead, it reminds us that to ancient humans, meat was meat. The line between us and food was much thinner and more porous than it is today. It's an uncomfortable truth that our history isn't just one of survival, but of a pragmatism so deep it challenges our modern morality. Our ancestors were survivors first, and everything else second. They ate what they had to, and they used every tool at their disposal to ensure that their children wouldn't be the ones ending up as someone else's dinner. The further we look into the past, the more we realize that there is no such thing as a single, natural human diet. We didn't evolve to eat meat, or to eat plants, or to eat grains. We evolved to be the ultimate generalists. We are the only species that can survive in the Arctic on a diet of 90% seal fat and also thrive in the tropical rainforest on a diet of fruit and insects. This flexibility is our greatest evolutionary superpower, but it's also our greatest modern curse. Because for 3 million years, the rule was simple. If you find something high in fat or sugar, eat as much of it as possible, because you don't know when you'll find it again. That rule is still hardwired into your brain. When you see a tray of donuts or a greasy burger, your brain isn't seeing junk food. It's seeing a bone full of marrow or a hive full of honey. It's seeing survival. The problem is that in the modern world, the marrow never runs out. We are living in a biological mismatch, using an ancient survival program to navigate a world of infinite, cheap calories. We are still that scavenger on the savannah, but we've been given the keys to the entire warehouse, and we don't know how to turn the hunger switch off. This journey through time brings us back to that mundane sensation we started with, that tiny bit of grit or the feeling of your teeth grinding together. You probably don't think about your teeth very often, except perhaps when you're at the dentist or when something gets stuck in them. But your teeth are essentially the historical records of your survival. Every ridge, every microscopic scratch, and every cavity is a testament to the fact that your ancestors figured out how to eat the world. They cracked the code of the savannah, they mastered the fire, and they learned how to turn a handful of wild grass into a loaf of bread. But they did so at a cost. We changed our bodies, we shrunk our guts, and we rewired our brains all for the sake of the next meal. And while that hunger is what built our civilizations, it's also what is currently making us sick. We are the first humans in history who have to consciously decide not to eat, a concept that would have been completely alien to every person who lived before the last 100 years. To them, hunger was a constant companion. To us, it's a lifestyle choice or a medical condition. If you could bring an ancestor from 2 million years ago into a modern grocery store, they wouldn't see food. They would see a miracle. They would see rows upon rows of marrow and honey that required no risk, no stone tools, and no long-distance chases. They would likely eat until they collapsed, unable to comprehend a world where calories are a threat rather than a prize. But as they looked around, they might notice something strange about us. They might look at our smaller jaws, our crowded teeth, and our soft, processed foods and realize that we've lost the very thing that made us human in the first place: the struggle. We have won the 3-million-year-old war for food, but in winning, we have become victims of our own success. We are still running that ancient software, still scanning the horizon for the next big kill, even when the only thing on the horizon is a vending machine. It's a strange place to be, the most well-fed animals in the history of the planet, yet still deeply, primally hungry for something we can no longer define. So, the next time you feel that tiny piece of grit in your teeth, or that slight ache in your jaw after a long meal, don't just brush it off as an annoyance. That sensation is a direct link to the scavengers, the hunters, and the first bakers who paved the way for you to be here. It's a reminder that your body wasn't built for comfort, it was built for the grind. It was built to crack bones, to chew tough roots, and to survive on the margins of a world that didn't care if you lived or died. Your teeth are the oldest tools you own, and they carry the marks of a history that is much longer and much more brutal than we usually care to admit. And let's be honest, your dentist is probably right about the flossing, but they're only seeing the last few millimeters of a 3-million-year-old story. We are the survivors of 1,000 famines, the children of the marrow eaters, and that hunger is never going away. It's not just a craving, it's our heritage. And that's something to think about the next time you're standing in front of the fridge at midnight, looking for something to satisfy a ghost that's been haunting your DNA since the dawn of time. If this deep dive into our ancient menu changed the way you look at your next meal, you might want to stick around for our next investigation. We're going to look at the other side of the coin, not what we ate but what was trying to eat us, and how that shaped our social structures and our fear of the dark. It's a rabbit hole that goes even deeper than this one. In the meantime, I'm curious. If you had to live for 1 week on the diet of a specific era, would you choose the marrow-heavy scavenging of the early Homo species or the high-carb grain and honey diet of the early sapiens? Let us know in the comments. We're genuinely interested to see which version of the past sounds more or less appealing to you. And remember that tiny, irritating ridge on the back of your tooth that we talked about at the very beginning? The one you can feel right now with the tip of your tongue? It's not a flaw in your anatomy, and it's not just a bit of leftover lunch. That ridge is a Carabelli trait, a tiny cusp often found on the molars of modern humans. It's a physical scar of our evolution, a structural reinforcement designed to handle the immense pressure of a life spent grinding, tearing, and processing a world that wasn't meant to be eaten. It's a definitive, permanent reminder that you are a predator that learned to cook, a scavenger that learned to farm, and a creature built specifically to consume everything in its path. You might be sitting in a climate-controlled room with a full stomach right now, but your mouth is still a weapon designed for a war that ended 10,000 years ago. You aren't just eating your lunch, you are the living evidence of a 3 million-year-old massacre. That grit in your teeth isn't an annoyance. It's a trophy. And it's the only reason you're still alive to feel it.